All right, welcome back everyone to the deep dive. We're going to be taking a look at robot framework today, and this is something that has been coming up quite a bit in stuff that you've been looking into in terms of automation and frameworks and all that. So I thought it would be fun to do a deep dive on this tool, this robot framework, and try to get a better understanding of its purpose and where it excels and how it differentiates itself from all the other automation tools that are out there. So when we look at robot framework, what is like at its heart, what is robot framework? It's open source, right? And it's a framework. But what does that mean? What is it? So it seems like it's a very versatile framework, and it can be used for both test automation, so making sure that, the software is working the way it's supposed to, but also for RPA, which is robotic process automation. So essentially teaching software robots to mimic human actions. And that's really interesting because, it kind of has this dual purpose.
Yeah.
And I think that's part of its power and part of what makes it so versatile. Now, it wasn't always this broad in scope. Initially, it was primarily focused on acceptance testing, so verifying that the software was meeting the needs of the users of the business. But it's grown considerably since then, and it now encompasses a much wider range of testing types and even just general automation tasks, which is pretty exciting. I think one of the things that makes Robot Framework really stand out is its keyword-driven approach. So you can think of it like this. Imagine you have a toolbox, right? And it's filled with all these pre-built actions. That's essentially what keywords are. They're reusable components that really lower the barrier to entry when it comes to automation. So even if you don't have extensive programming skills, you can start putting together automated processes. And one of the coolest things about this is that it's not a closed system. So Robot Framework is incredibly extensible through what are known as keyword libraries. Now, these libraries, they're essentially collections of keywords, of pre-written keywords that can be created either by third-party developers or even custom built by your own team to address very specific automation needs. And this extensibility means that you can use Robot Framework to automate interactions with a huge range of different technologies, from user interfaces, those are the things that we see on our screens, to APIs, which are the ways that software systems talk to each other behind the scenes, to databases, to all sorts of different systems. So let's dig into specifically how it's used in test automation. We're going to look at all the different levels of testing and how Robot Framework can be applied. And it seems like it really shines across a variety of levels. For example, it's used in system testing, which is verifying that the complete system as a whole behaves correctly. And that's not just the core functions. It's also about non-functional aspects like accessibility, how easy is it for everyone to use, and security, making sure that it's protected from threats and vulnerabilities. And sometimes in system testing, you might even use simulated components to kind of test specific scenarios. Then we have system integration testing. This focuses on how the system interacts with other systems, with external services, with the outside world. And it's all about making sure that when we bring different software pieces together, they can communicate effectively and function as a unit. Then we move on to acceptance testing. And acceptance testing is crucial. This is where we validate whether the system actually meets those business needs, if it's truly ready to be deployed. And acceptance testing can take many forms. There's user acceptance testing, where the intended users actually get to try it out to see if it meets their needs. Operational acceptance testing to ensure that it can actually be run and maintained effectively in a real-world environment. And even regulatory acceptance testing to ensure compliance with all those rules and regulations that might apply. And what's interesting about this is that often acceptance tests are written or performed by the end users, by the stakeholders themselves. And that makes sense, right? Because they're the ones who are ultimately going to be using the system. They're the ones who know best whether it meets their needs. Now, this connects directly with a concept called ATDD, which stands for Acceptance Test-Driven Development. And in ATDD, the business stakeholders are really actively involved in defining those tests up front, from the very beginning of the development process. Now, using Robot Framework to automate those acceptance tests early on, that's super powerful. It gives you really fast feedback, and it can help prevent costly rework later down the line if issues are found, much later in the development process. And finally, we have end-to-end testing. So this is about verifying a complete process or a user journey from start to finish across all those interconnected subsystems, interfaces, and any external components that might be involved. It's really about simulating that real user experience as they move through the entire application. And this is where the flexibility of Robot Framework combined with the wide range of libraries that are available, this is where it really shines. It helps to ensure that not only the individual components are working correctly, but also that they all play well together, they interact seamlessly, and that the overall system behaves as expected, even in those really complex production environments. However, it's also important to understand that there are some areas where robot framework might not be the ideal tool, might not be the first choice. For instance, when we look at component testing, this is where we're focusing on very granular, very low level testing of individual units of code. And this is often done using techniques like mocking and stubbing, where we kind of simulate dependencies. For that, there are unit testing frameworks out there like JUnit, like PyTest, like InUnit that are specifically designed and really well suited for this kind of detail for working at that level of the code. And similarly, when we're talking about very low level integration testing, where you need a lot of control over how the services are communicating with each other, maybe even working with API stubs or manipulating those network protocols directly, Robot Framework might not be the most efficient tool for that. You could technically achieve it by creating custom libraries, but its core design philosophy really leans towards higher level testing, behavior driven testing, and that keyword based approach. So it's not to say that you couldn't use it for these things, but it might add unnecessary complexity. It might add overhead to the process. So we've talked about test automation, but now let's shift gears and talk about RPA, robotic process automation. So the core idea of RPA is really about using software bots to mimic those repetitive rule-based tasks that humans would traditionally perform. And what's interesting is that RPA tools, they often do this by interacting with the existing applications through their user interfaces, just like a human would, without needing to change those applications themselves. Now, it turns out that Robot Framework has become very popular in the RPA space. And I think this popularity stems from a few key factors. First, there's that keyword-driven approach that we talked about earlier. It's very accessible, even for people who don't have, extensive programming backgrounds. Second, there's this vast collection of libraries that are available for interacting with different systems. And third, it's relatively simple to get started with, and it can be scaled to handle quite complex automation needs. And because of this design, you can automate all sorts of different workflows using those ready-made keyword libraries that offer a whole bunch of functionalities out of the box. And as we mentioned before, you can combine and reuse those existing keywords to create your own more complex user-defined keywords. And that not only simplifies the automation process, but it also makes it a lot easier to manage and maintain over time. Now, if you do encounter tasks that are really unique, really complex, or if you need to integrate with some really specific system, Robot Framework lets you create your own custom keyword libraries, and often that's done using the Python programming language. Some of the common RPA use cases that we see out there include data extraction and manipulation. So automating the process of taking data from different sources, transforming it as needed, and then sending it to other systems. And then there's general task and process automation, which can be things like filling out forms online, clicking through a series of actions in a web application or even desktop application, and managing files based on some predefined rules. So let's dig a little bit into the architecture that makes all of this possible. What's interesting is that Robot Framework is not really a single, all-encompassing automation platform. It's really designed more as a foundation, a flexible foundation. And it relies on this whole ecosystem of tools, libraries, and integrations to achieve specific automation tasks. Now, its design, it aligns really nicely with what's known as the Generic Test Automation Architecture, or GTAA. And this comes from the ISTQB, which is the International Software Testing Qualifications Board. And this architecture, it really helps us to think about the different aspects of test automation in a structured way. It breaks it down into these logical layers. So the first layer in this GTAA model is the definition layer, and this is where all of the test data lives. In the context of Robot Framework, this includes your test cases, the specific tasks that you want to automate for RPA, and any resource files that might contain your custom keywords that you've defined and any variables that you're using. And this information is written in Robot Framework's specific syntax, which is actually human readable, which is really nice. And it's typically organized into test suites, which then contain the calls to those keywords, along with any necessary arguments or data. Then we have the execution layer. So in Robot Framework, this is the heart of the framework itself. This is the engine, so to speak. And this layer takes that test data that we just talked about. It parses it,
Okay.
it understands it, it figures out what needs to be done, and then it builds an internal representation of that execution plan. And then it orchestrates the whole execution process. It calls those keywords from the various libraries, it passes the arguments, it manages all of that. And it plays a really crucial role in logging all the details and generating those reports that summarize the outcome, which is really important for understanding what happened during the test. And finally, we have the adaptation layer. So this layer is like the bridge that connects Robot Framework to the system under test, or the SUT. And that could be a software application if we're talking about testing, or it could be any other system that we're trying to automate with RPA. This is where those keyword libraries really come into play. They contain the code that actually knows how to talk to these different technologies and interfaces, whether it's manipulating things on a web page, sending requests to an API, querying a database, interacting with desktop applications. All of that happens in the adaptation layer. And these libraries, they are what make robot frameworks so adaptable to such a wide range of technologies and environments. And it's worth noting how the various editors and IDEs that are out there that support robot framework fit into this layered architecture. So when you're writing your test cases, when you're defining new keywords in an editor, you're primarily working within the definition layer. When you're executing those tests, when you're debugging them, you're interacting with the execution layer. And if you're writing the code for those custom keyword libraries, which often happens in Python, then you're working in the adaptation layer. And all those extensions and plugins that are available for Robot Framework, they can also be categorized within these three layers. So to really clarify things, let's talk about what Robot Framework is at its core and what it's not. Fundamentally, its primary focus is on the execution of tests and tasks. It's about providing that engine that can read your test and task definitions, understand them, figure out what needs to be done, and then actually go out and do it by invoking those keywords that you've specified. It also handles all those important tasks like generating detailed logs and summary reports so you can understand what happened. And it includes some basic standard libraries that are useful for common tasks like manipulating data, interacting with the file system, working with processes. And it has well-defined APIs that let developers extend the framework and customize it to their needs. Now, what Robot Framework does not include out of the box are those keyword libraries that give you the specific instructions for interacting with those systems that you want to test or automate with RPA. So you won't find built-in keywords for controlling web browsers, for making API calls, for working with mobile applications, for dealing with databases, or for RPA-specific tasks. All of those things are handled by external libraries that you need to install separately. Similarly, Robot Framework itself doesn't come with an editor or an IDE. There are great editors and IDEs out there that support Robot Framework development, but those are separate tools. And finally, while you can integrate Robot Framework into your continuous integration, continuous delivery pipelines, CI/CD pipelines, it doesn't have built-in CI/CD features. You achieve that integration through other tools that are part of that CI/CD ecosystem. So the role of those external libraries and tools, it's crucial. They are what really extend Robot Framework's core functionality and let it handle all those different automation needs. And finally, let's touch briefly on the technology behind Robot Framework and what you need to get started. So it's built on Python. That gives it a lot of flexibility and allows it to tap into that huge and active Python ecosystem with all those libraries that are out there. To run Robot Framework, you need a supported Python interpreter on the machine where you're going to be running your tests or tasks. And you typically install it using pip, which is the standard package installer for Python. Robot Framework in its core form doesn't have any external dependencies other than Python itself. But those third-party tools, those keyword libraries that you'll likely be using, they will often have their own dependencies that you need to manage. So to wrap things up, Robot Framework, it's really a powerful and accessible approach to automation, and it excels particularly at those higher levels of testing where we're looking at the system as a whole, how all the pieces fit together. It's got this keyword-driven nature that makes it easy to use, and it's got this amazing ecosystem of libraries that support all sorts of technologies and automation use cases. We've seen how it's really strong in system testing and acceptance testing and end-to-end testing, and we've seen how it's becoming more and more popular for all those different RPA applications. And I hope that this deep dive has given you a good understanding of what Robot Framework is, what it can do, what its strengths are, and where it might be the right tool for your needs. And I think it's worth considering that with its reliance on all those external libraries, it's really a constantly evolving tool. So it begs the question, what new technologies, what emerging areas do you think the Robot Framework community might focus on next to expand its capabilities even further? What new possibilities might they unlock? That's something to think about as you explore the world of automation. And we'll be back next time with another deep dive.